Hello, students, and welcome to this new explainer. Today, we're going to dive into a really interesting topic, number systems. You know, it's the foundation of all of math, and we're going to understand it in a super simple way. So tell me honestly, do you also get a little scared when you see those big numbers, massive powers, and complicated calculations in math? If you said yes, don't you worry. Today, we're going to crack the code of these numbers and make every single concept incredibly easy. Trust me. All right, let's take a quick look at what we'll be covering. This is our roadmap for today. We're starting with the absolute basics. What are numbers? Then we'll understand the number family tree, learn the difference between prime and composite numbers, and finally, we'll learn a super useful exam trick for finding the unit digit. Ready? Let's get started. So, first things first, what even are these numbers? Well, you can think of them as the bricks of the giant building we call math. And if the foundation is strong, the building will be strong too, right? So let's start with the very first type. Here they are, natural numbers. These are basically all the counting numbers, which are positive integers. An integer is just a whole number with no decimals or fractions. I mean, whenever we start counting something, we always start with 1, don't we? 1, 2, 3, 4, and so on. That's it. Those are your natural numbers. It's that simple. Okay, but just think about this for a second. What happens if we invite 0 to join this family of counting numbers? Does the family get a new name? Absolutely. The moment we add 0 to our natural numbers, the 1, 2, 3, and so on, we get a whole new set, and we call these whole numbers. So what this means is that all natural numbers are whole numbers, but not all whole numbers are natural. And who's the reason for that? Just one number, 0. Now let's make the family a little bigger. Rational numbers are all those numbers that we can write in the form of p by q, basically, as a fraction. This includes negative numbers, like -7, and, of course, fractions, like 2 by 3. The bottom line is, if you can turn it into a fraction, it's rational. And now, let's meet the slightly more mysterious members of the number world, irrational numbers. These are the numbers that we just can't write as a simple fraction. Their decimal value just goes on and on and on without ever repeating. The most famous example of this is, of course, pi. Okay, now let's see how we can classify numbers in even simpler ways. Just imagine it's a small family tree with 2 main branches. Now, this is something we've all been learning since we were kids. Even numbers are those that can be completely divided by 2, and odd numbers are those that can't. The concept is simple, but it's going to be really useful later on. All right, let's move on to a very important topic, one that's a favorite in competitive exams, prime and composite numbers. It's really important to understand these. So just think for a moment, what's so special about a number that makes it prime? Does it have some kind of special power? Let's find out. A number is called prime only when it can be completely divided by just 2 numbers. One is the number 1, and the other is the number itself. For example, take the number 7. It can only be divided by 1 and by 7, and nothing else. That's why it's a prime number. So to put it simply, the only difference between them is this. If a number has only 2 factors, it's prime, and if it has more than 2 factors, it's composite. For example, the number 6. It's divisible by 1, 2, 3, and 6. That's more than 2 factors, so it's a composite number. Okay, you need to make a note of this point. You get direct questions on this. The number 2 is the world's only even number that is also prime. Every other even number is composite because, well, they are divisible by 2. This is a very important tip. All right, let's move away from theory and learn a practical exam trick. This section will help you save a lot of time in your exams. We're going to crack the code of the unit digit. Just imagine this question pops up in your exam. You have to multiply 342 by itself 235 times and then find the last digit. Doing this manually is, well, it's impossible. So what's the shortcut? The secret is cyclicity. You see, the unit digit of the powers of any number repeats in a fixed pattern. As you can see in this table, the unit digit of the powers of 2 repeats after every 4 powers. It goes 2, 4, 8, 6. And then the pattern starts all over again. 2, 4, 8, 6. We're going to use this exact pattern. Okay, let's break this down step by step. Step 1. First, look at only the unit digit of the base, which is 342. The unit digit is 2. Step 2. Now remember, what was the cyclicity of 2? It was 4. That means the pattern repeats every 4 powers. Step 3. So now we divide the power, which is 235, by the cyclicity number, 4. Step 4. When you divide 235 by 4, you get a remainder of 3. And this remainder is our key. Step 5. Our final answer will be the base's unit digit raised to the power of the remainder. So that's 2 to the power of 3, which is 8. See? How simple was that? And to save even more time in exams, here are a few more quick shortcuts, especially for the numbers 4 and 9. If the unit digit of the base is 4 and the power is an odd number, the answer will always be 4. If the power is even, the answer is 6. It's a similar rule for 9. If the power is odd, the unit digit is 9, and if it's even, it's 1. These rules will save you a ton of time. So today we saw that numbers aren't so scary after all. From natural numbers all the way to unit digit tricks, there's a logic, a pattern, behind everything. And once you understand that pattern, math becomes easy.
Every number has its own story, its own puzzle. Today, we solved a few of them. Now just think, which puzzle are you going to solve next? अगर आपको ये वीडियो हेल्पफुल लगा हो तो प्लीज़ लाइक, शेयर और चैनल को सब्सक्राइब करना मत भूलना। सारे PDFs के लिए मेरा टेलीग्राम चैनल ज्वाइन करें, लिंक डिस्क्रिप्शन में है। कीप वॉचिंग एंड स्टे ट्यून्ड।